Alright class, our lesson today is going to be over similar triangles. Our objective for today's lesson is that students will be able to identify a pair of similar triangles using different proofs. Example as in SAS, AAA, or SSS. So to begin the lesson, you could start by showing the students different pairs of similar triangles, such as this pair I have right here. Ask the students if these triangles are similar triangles. If they believe so, how do they know? This will get the students' critical thinking juices flowing, and if and why these triangles are similar. How can things be different sizes and related? What does similar mean? All these questions you'll be addressing in the lesson today to help students understand what similar triangles are and why they work. So, for the sake of this lesson, we're going to assume that children have already been taught what ratios are previous to this lesson. So today's lesson explanation portion is going to begin by introducing the terms and definitions that students will need so they have a solid base of information about the terms. So first, we're going to look at similar triangles. So, to be considered a similar triangle, you would first tell the students that all the angles are equal. That's the first requirement of being a similar triangle. The second is that corresponding sides have the same ratio. So these could be displayed on the board throughout the lesson so students can reference back to these as you are moving through the lesson. And ratio, just so they have a little bit of knowledge as they're going into this, even though they've already reviewed it, is going to be a ratio says how much of one thing there is. If I can fit it all in the screen, is compared to another. And like I said, the students are already going to have a very good base of what ratios are from the previous lessons. So from here, we could start by going to the first proof, which is going to be SAS. So, SAS, you're going to be explaining to the students, stands for side, angle, side. And that means that we have two triangles where the ratio between two sides is the same as the ratio between another two sides. So, for example, we have this down here. In this example, we can see that one pair of sides is in the ratio of 21 to 14. It's going to be this side to this side. So 21 to 14 has a 3 to 2 ratio. And again, they previously know how to find ratios with division, being able to find that this would have a ratio of 3 to 2. The other pair of sides has a ratio of 15 to 10, 15 to 10, giving them a ratio of 3.2. 3 to 2. So this would show, this would be two of the requirements. These would be the side and the side. So now we have to find the angle. So there is a matching angle of 75 in between them. There's 75 and 75. So these would be, in fact, similar triangles. This checks out because you have the ratio between two sides is the same. 3 to 2 and 3 to 2. Oops. 3 to 2 and 3 to 2. And then you also know that included angles are equal. 75 and 75. So for the second, we're just going to be working on the same triangle, and that is going to be our angle and angle. So I've written in our example. So for this one, it's pretty easy to see that we have similar angles between these two. We have 75, 75, 60, and 60. So by quick math, we could add up these two on either side and subtract it from 180 to find our missing angle. And that would be right here and right here. And since we know that all three angles must add up to 180, we know that this is a similar triangle with angle, angle, angle as the proof. So the last one, also very easy, is going to come from all three sides. It's going to be side, side, and side. So all the sides have to be similar. We have 15, and this is going to deal with ratios as well. So we know that our ratio from the previous example, 3 to 2, 3 to 2. Now we can find this a and this x through Pythagorean theorem, so that we'll be able to see that the triangles are indeed similar. Alright, so those are the 3 proofs that we went over. So we have, remember, side, 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 and angle, angle, angle. Those are our 3 proofs to show whether or not a triangle is similar or not to another. So to wrap up this lesson, you could give the students, a pair of students, a poster. They will have to list the requirements for 2 triangles to be similar, as well as what this means to be similar. Each group will explain the different proofs, AA, SAS, as well as SS. And they will need to demonstrate a pair of similar triangles that can be identified using each of the proofs. These posters will come in. These posters will be helpful reminders to students and allow them to show their understanding of the concept, and they can reference them at whatever time as they're going through the lessons on congruency, and the lessons that get a little bit harder, they will be able to reference these to learn the basics. The follow-up will be a worksheet that allows them to look at different pairs of triangles and decide if they're similar or not. All right.